The vertices of a quadrilateral ABCD have coordinates A into -1, 5, B 7, 1, C 5, -3, and D -3, 1. We need to show that ABCD is a rectangle. As we all know, when we speak about rectangles, it means that the pair of opposite sides are parallel and equal. So first thing we need to do is to find the slope of AB, of BC, of CD and DA. Comparing the slopes, we will check the parallelism relationship. Then we have to use the distance formula to find the length of each one of those segments, and then we compare to see whether they are equal or not. And the third thing, which is proving that one angle is equal to 90 degrees, and this can happen when we are comparing the slopes of the adjacent sides. So let us start. First of all, we will have the slope of AB is equal to y2 minus y1, so 1 minus 5 over 7 minus 1, so this is -4 over 8 equal -half. Then the slope of BC is y2 minus y1, so it's -3 minus 1 over 5 minus 7, so this is -4 over -2 equal to 2. We will calculate the slope of CD. It is 1 minus -3 divided by -3 minus 5, so it is equal to 4 over -8 equal -half. And then the slope of DA, which is equal to y2 minus y1, so it is 5 minus 1 divided by -1 minus -3, so this is equal to 4 over 2, which is equal to 2. If we are looking now at the results that we obtained, we notice that -half is equal to -half, and 2 is equal to 2. So now we can conclude from comparing the slopes. This implies the slope of AB is equal to the slope of CD equal -half. So AB is parallel to CD. Also, if we compare 2 is equal to 2, so the slope of BC is equal to the slope of DA. So this implies that BC is parallel to DA. So now we will conclude that ABCD is what? It is a parallelogram. So now if we can prove that the adjacent sides are perpendicular, forming an angle of 90, then this will be a rectangle without using the distance formula. So now if we look at the slope of AB multiplied by the slope of BC, then this is -half multiplied by 2, which is equal to -1, which implies that AB is perpendicular to BC. So then ABCD is a rectangle. So as we know, a parallelogram with one right angle, it's a rectangle. So using the slope to prove that the lines are parallel helped us to avoid using two different formulas. So we used the slope formula once, and then we have concluded that the opposite sides are parallel, so it's a parallelogram. Using the product of the adjacent sides, we proved that the lines are perpendicular, so we have one right angle, and this is enough to get us to prove that ABCD is a rectangle. The other method, we can use the distance formula. We will prove that the two opposite sides are equal, and then it is parallelogram, then we have to prove that one angle is right, so we will use the slope to prove that the adjacent sides are perpendicular, and then the parallelogram is a rectangle.